In this video, I'm going to show you how to use the prop.test function to perform a left-tailed test for a single population proportion. The way you're going to go about doing this is you're going to need to have a set of hypotheses. So I'll use these ones right here. We'll have a null of p equaling 0.3 and an alternative of p being less than 0.3. Then we need to have a significance level or a decided upon probability of a type 1 error. And based upon that, we can set up a rule for rejecting our null hypothesis, which will look like this. We'll reject if our p-value is smaller than a significance level. And then what we'd actually need to do in real life is go out and collect a sample and check out if it meets all our assumptions there so we can know that the results are good for this. So we need to have a simple random sample, and then we need to have a sample size large enough so that both of these conditions are true here, that n times a p0 value and n times a 1 minus p0 value are going to be both bigger than 10. So the p0 value here is actually this 0.3. So we'd have to check to see if, in this case, 100 times 0.3 is bigger than 10. And we'd also have to check to see if 100 times 1 minus 0.3 is bigger than 10. In both those cases, that's actually true. So we know if we had actually a real sample here, our results would be sort of reliable and they'd have a chance of a type 1 error of being 0.05, or we would have a procedure that would have a chance of a type 1 error of 0.05, I should say. And now how do I go about doing my calculations for this? Well, this is where I can pull out the prop.test function. And what I have to put in there is, first off, my number of successes. So in this case, I had 25 successes. Then I have to put in my sample size. Then I'd have to type in what my p0 value is so it knows how to perform the calculations. Well, the p0 value is 0.3 in this case. Then I'd have to tell it what type of alternative I need. In this case, the alternative is a less than alternative, just like that there. So I just say alternative equals, and it wants less. And then we'll leave everything else on the defaults. It does make a little bit of difference in terms of the results, but it's not going to make that big of a difference, so we won't worry about it. And so I'll go ahead and I will run this. And if we look down here, we'll see the three important lines are basically right here. First one, we can check out to make sure we use the right null probability. Well, we used 0.3 there. We can make sure that it's using the right alternative. The true p is less than 0.3. That's correct. And then we can look at our p-value to check our results. And we can say, well, is that p-value less than our significance level we have right here? Is 0.1631 actually smaller than 0.05? That is not the case. So this is a case where we would decide to fail to reject our null hypothesis. And just keeping this simple here, this doesn't have any kind of nice interpretation at the moment because all these are just sort of made up numbers for us. But you can see how you'd go about putting the numbers in here. So that's how you can use the prop.test to do a hypothesis test or a left-tailed test for a single proportion.